The short answer is that we'd rather spend our time building KRL than tracking JavaScript directly. The additions that they're adding are very cool. There's some amazing speed advantages in the other things that we're doing, but it would turn out that we wouldn't get as much return for our development time if we were following it too closely. And so we let them get to their stable release and run through all of their own testing procedures before we roll it into our library. Okay.
You might mention, though, that we do have Selenium do testing.
So Phil's bringing up that I should mention what we do to test our JavaScript library. We're building this, it's not only jQuery, but we have a lot of things built on top of jQuery that drive the Kynetx system. And we have built a testing engine that uses Selenium to automatically run our library, not only on one website with all of our functions, but across many websites so that we can see how our library behaves with other people's websites. Since this is basically what we're doing. We're planting our library on other domains that we don't control, and we want to make sure that it works the way that we expect. We do run into sites where there's conflicts, and most of the time we can work around those to resolve whatever conflict there is so that their site continues to run and everything behaves inside of KRL the way that you would expect. So emitting JavaScript can be painful, not just because it's JavaScript and you have to deal with all the issues yourself, but because the JavaScript that you're running is actually running on other people's websites typically. And that makes it really hard from a debugging perspective, because if your JavaScript breaks, not necessarily because of a change in your own code, but because of a change in the target website, you're now left helpless and you have no idea that actually occurred. So this presents a problem, and the way to solve that is by using an error tracking system that will track the errors that occur within your own code on other people's websites and report it back to you so that you can do some debugging. What I show here is an example of the application of a system called ErrorStack, that you can use in a try-catch block to wrap your own code. And you've clearly seen that I'm dividing by 0 here. And that this will catch the exception and log it to this system called ErrorStack, which makes it available to you. It can alert you that there's errors, and you can see the details of those errors, even though they're happening across multiple websites. And so I'd like to invite Tyler Whitaker up. He's from ErrorStack. We've partnered with them to make it easy to do this in order to allow you to
Mike?
Does Mike have the mic? Where's the mic?
There's one right there. Great, thanks, Sam. Okay, great. I'll just take a minute here to talk a little bit about ErrorStack. ErrorStack is an error-based reporting system that's in the cloud. So with applications that are spread clear across the web, the real challenge is trying to debug those, trying to know exactly what configuration management issues you have, to know when Safari breaks your website, or when some small change in some weird library that is running on some other website breaks your Kynetx code. You need a way to be able to find those bugs and fix them quickly so your customer experience doesn't suffer. So what ErrorStack is it's a cloud-based error reporting solution that uses a very simple REST-based API to be able to take schema-loose data from you and present that back in a very meaningful way so you can analyze that and narrow down those bugs very quickly. It was really built out of a need to track errors on client-side AJAX sites, and since then it's blossomed into we've got code libraries for iPhone developers to track iPhone errors. We've got Python code, we've got .NET, C#, ASP.NET code, Cold Fusion. Gosh, it just keeps coming and coming. We have developers all over the world now that are submitting libraries to us to use this API. So in conjunction with ErrorStack, Sam's going to talk a little bit more about the ways that we've integrated, and we've got some more integration paths that are going to be coming up in the next couple weeks and months. But we're really excited to be partnered with Kynetx, because we think that our product really enhances theirs, and theirs definitely enhances ours. And so we're excited about some of the things that are coming along. So accounts are free. There'll be a freemium model. Right now we're still in beta, so have fun, kick the tires, use it to your heart's content. So we just love the feedback. Thanks.
Thanks, Tyler. So, in error stack, each collection of errors is called a stack within error stack. It has a key, and you'll see a key looks like this, and you'll get that when you actually make the stack. So I'm going to show you 3 different methods of tracking your errors within error stack. This is the first one, where you have a try-catch block, and there's this block of code that actually does the error stack submission right here. To make it a little bit easier, we've actually wrapped this into the runtime. And so you can actually just call KVJ error stack submit with your stack key and the E that came from the catch block here. You'll see that here's the E. So instead of writing all that code, you can do this with a one-liner. And it will actually use that same code basically wrapped up into the runtime to make it easy to do. If that's not easy enough, we've actually added an option right here within error stack. If you declare the key for error stack inside of your meta block, we will wrap all emitted JavaScript for your application in a try-catch block that submits the error back to error stack. And so what you want to do is simply make this declaration in your meta block with whatever your stack key is, and all the errors that your application generates will funnel directly back into error stack for your analysis and fixing. And if that isn't easy enough, then I don't know what is. Question?
Is there any reason not to use this method? I mean, you just showed us 3 different methods.
This is what I would go with. If you have an advanced application and you want to track different areas of the application in different ways, you can do that by specifying the stack key at the time of error submission. So if there's a portion of your application where you want the errors to go to a separate stack, then that's why you use the other methods. If you want to, the reason to use the full code block method is if you want to customize the data that's actually being sent and include some of the variables that are available within KRL and therefore JavaScript, you can actually modify the code directly to submit any additional information back to error stack as well.
How would you make this key? This is what I meant.
That error stack generates that. Yeah, it's just a long key that it gives you for what you have multiple stacks, and then each stack can be shared among multiple people. So if you're working with other developers, you can all look at the same list of errors, and you don't have to like spam the world with email error reports. So if you're writing advanced JavaScript applications and you are not using a logging method, use it. It will make your life easier. You'll be able to detect errors that happen on other people's sites within your code and allow you to rapidly fix the errors and present a better experience to your users. Any other questions about errors? Okay, so
Sam,
yes.
how long does it take from the time the error occurs to when it shows up on error stack?
So the question is how long does it take from the time that the error occurs to show up on error stack? And the question is, it sort of depends. It gets submitted to error stack, bounces through their engine, and either appears on the website, or they have error stack has a downloadable error-based app that it'll pull the error down to for analysis as well. And so I think it takes anywhere from 30 seconds to a couple of minutes, depending on what's going on. So yes, it can be.
The website's immediate. I mean, within a second or two. What Sam's talking about is in the desktop error app, there's a polling interval of up to a minute or 2 minutes.
So the website, Tyler's saying, is will give you the error nearly immediately. If you're doing this in testing, you're going to want to get the errors directly back to your browser. And I'm going to dive right now. I'm actually going to skip Wade. We're going to talk about some other stuff, but I'm going to skip Wade because we're short on time and I don't want to delay lunch. You stretching? Okay. So I want to talk about other ways of debugging. Of debugging applications, and I'm going to go over to a site which features a product which we should all be highly interested in to actually do this. And on here, I have running the code that I mentioned before. So you see the alert that I'm running. So I called alert with test alert, and this is the emitted JavaScript that I'm running. And so I'm going to fire a Firebug here, and I'm going to reload this so that it gives me the original information. There's a bunch of debugging information that we can actually display and spit out on this stuff. What's that? Expand?
I can't see. I can't see. I'm on the front row.
So Firebug is a tool that allows us to inspect things within the browser that's really, really handy. So there's a couple of different features of Firebug that I'm going to detail here that are really useful. The first one is the console. The console will give you information back from your JavaScript application. when Firebug is enabled within